We are live. So we'll give it a couple more minutes, see if anybody else is going to hop on. I know a couple of the students can't make it today. So it looks like everybody's doing a lot better than they did the first week. I just graded like the fourth homework, and yeah, everybody's coming along. Today's going to be a bit different, and I am it's very relevant. I'm to like a consulting job I have right now where I'm building an OLAP database. And I haven't done this in a long time, like the way that it's in here. And I'm like, this is actually really helpful. Can somebody confirm this works? So I'm trying something different. Did the slide change on the stream? Can you only see the slide? Sweet. Oh, it's okay. I'll take your word for it. Oh, nice. All right. All right, so let's go ahead and get started. Today, we're going to go over structuring and modeling data. We're going to talk about OLTP databases, relationship diagrams, normal forms, data flow modeling, OLAP data models. We're going to do some exercises together, talk about Class 7's homework, and then, or not homework, the focus for Class 7, and then off to a homework assignment. First, just a little review because repetition's our friend. So, creating databases, why do we do it? Because we want nice, structured, organized data that we can capture. We've talked about cleaning, adding, removing, modifying data, how to get records the only records that we want. That's going to be pretty relevant today as we get into what's the difference between OLTP and OLAP databases. But something I would encourage you to do, not today, but just something to think about once you get the technical stuff down, and even if you don't have it down yet, and you find yourself either working in this field or you have a client and you're doing data work for them, one of the most difficult skills to learn, which is actually harder than technical, is communicating. And it's like we think of metrics and KPIs, right? The devil's in the details. And how was that KPI created? You've got to know that stuff off the top of your head for the most part, right? You have to think through what the data is doing, And then you've got to explain it in a way that somebody who's no idea, like what any technical terms you're saying is going to come out of your head, they're not going to understand it. And so the exercise here is like, learn how you're speaking to your mom or a child, or, don't use jargon, think things through natural language. And if you find yourself like where you're maybe using too much jargon or technical language, or you're having difficulty or knowledge gaps, like go back and review it. Repetition's our friend. So our objectives today is we want to understand the purpose of database modeling, entity relationship diagrams, what relational database modeling is, what are these normal forms I'm talking about, what's analytical processing databases, versus transactional, and then we're going to walk through this Sequila database model. We're not going to load it or anything like that. We're just going to go over the diagrams and kind of walk through it. Okay, so what is database modeling? It's like a blueprint to an architect. You're drawing everything out so you can understand the relationships between tables. You can understand how data is flowing through different systems. And sometimes it can be something at a high level for you to just better understand it, or it's a very formal documentation of like a relational database, what tables are connected to what, which fields have keys. I in the past have at some points neglected putting detailed documentation like this together. That's only going to do you a disservice as I, became more seasoned over time. We've done some pretty simple tables and relations in this class, but when you get into the real world, it gets far more complex. And it just helps you. Like I said, when you're talking about how KPIs are generated, oftentimes you are joining from multiple tables, and you've got to understand how that join worked, right? Or you're trying to troubleshoot errors. So, think that your data model supports your systems. So, is it, is it like an inventory tracking system? Is it CRM or whatever it is? And then the data from that, can support your analytics. And then in your business, when you get to, you haven't experienced yet a real hardcore data-driven culture, it's pretty wild. Like people just talk in numbers and facts. Like they don't talk about emotions. They don't say, oh, this person does this all the time. They're like, hey, 75% of the time you're falling behind or whatever it is. And it's really nice because it takes all the kind of the, if you're having a difficult conversation, for example, it takes all the emotion out of it, right? And people listen. So it's really important for you to kind of walk that plane, from all the way at 30,000 feet. You're talking to a C-suite executive and technically land it all the way down on the ground. And these can help you do that. So what's the difference between OLTP versus OLAP? So OLTP is online transactional processing. Think of that as like it supports your operational processes. Maybe it's the like an ERP system in an organization. Maybe a component of it is the payroll system or human resource management system. Maybe if you're in healthcare, it's the electronic health record. That does sit on a database, and data does flow through different portions of that differently. Remember when I went back and we were talking about how to treat null values or dealing with messy data. One of the weirdest ones that I dealt with is, although everybody was on the same software system, we had a location that after they typed in a customer's name, they would hit enter, and for some reason the software actually made a return space in that name. But if you went and looked at the actual software, there's no return space, but in the database, it would create a return space, right? One of those simple things that took me about a week to figure out. So it's really understanding, that operational component of it. And then OLAP is going to be like what you would put in Tableau or like Power BI. You're creating your data model that you're specifically going to use for analysis. Database servers, as we've briefly talked about before, they come in all kinds of flavors. They have a finite amount of computing resources. If you're at a small business and they got a server rack, you're going to have struggles, most likely. You're going to have slow extraction times from getting the data, maybe slow insert times, probably go down a lot more, those types of things. And so, another differentiation I'll make is like OLTP, like in a modern architecture. You ever hear of NoSQL? Yeah, so NoSQL is the SQL database that supports applications. And so it's, if you imagine, instead of like, well, we've talked about a star schema, they may be broken out more like a snowflake, which we'll preview one here, where you're going to have a lot more smaller tables in your data model that are performing more functions as opposed to what you're going to have in an OLAP on the back end. So here's some database modeling techniques. You don't need to do them all this way, and you don't necessarily need to do all of them. I'll point out maybe the ones that I think are the most relevant on how to do it. So entity relation modeling, it's a logical model that's going to display like the entities and just basic relationships, one to many, many to many. Maybe there's some rules where it must be one to this, to many of that. Relational modeling is you're going to see the relationship between the various tables and how data is interacting. Data flow diagramming or modeling is what you see here. That's the flow of data. So if you imagine I got my login screen, and then I enter a bunch of stuff into a form, and I process an order for somebody, and then that order goes somewhere, and then it goes to an invoice, and then that invoice goes to the customer, and then their order goes to the supplier, and then the specs go to the factory. And so you see what I'm saying? Like, this is a pretty important part to think about. I have this saying, there's times to do A work, B work, and C work. And it's advantageous to you as a professional to understand when to do what. What I mean by that is data flow modeling. There's times where I may not spend a ton of time on it, like drawing different shapes and making it look all pretty, but maybe I just will draw some stuff out, just some squares and some flow diagrams and things like that to start to wrap my head around it. And then dimensional modeling, that's where we talked about like fact tables and dimension tables. So an example of that there is your fact table is going to be a bunch of sales. Maybe you have repeat customers and things like that. And then a customer table is going to have one record for every customer, maybe some additional information. So like your fact table will have a customer ID, but maybe it doesn't have a name or an address or phone number or anything like that. And then you can attach and join that customer table on the ID when you need it later. So OLTP modeling, online transactional processing, you're really focused on capturing events in the business processes. So your map is going to show the information stored relates to other data. Your ERDs are kind of more of a formal mapping process where you're going to have an entity and attributes of an actual table throughout steps in those processes. And then you can have a map of a database schema. Okay, so this, I don't know if this is that hard to see in the bottom right-hand corner? I know it's kind of small. Um, so in your ERDs, think of like your entities are nouns, your attributes or adjectives, and then your relationships are like the lines in between explaining how what the relationship is, between those two entities. So for example, like your entity would be your customer table, and then your attributes are name, address, their customer ID and things like that. And then your relationships. I think this one's pretty important to use. I know you can't see it well, and I'll blow up a picture and send it to you next because we'll go over this, or you'll see this pop up in class where um, when you were doing Tableau, did you have to deal with any cardinality and relationships between tables? Okay, this will definitely come up later on. And it can frustrate a lot of people. It's frustrated me a lot in the past where you load some data and you're creating your OLAP model in like Power BI, for example, and you're creating a relationship between two different tables, and it'll pop an error and say like, this relationship is circular, and it won't work. If you have a map there and you've already mapped out the relationships and cardinalities between tables, it's not really going to be a problem anymore. So it's a good thing it's a good practice to do that. Okay, so I'm kind of going to bounce back and forth between these next two slides. We're going to look at a business rule ERD example. We're going to look at some natural language and then pop over to a table, and I'll highlight some of these things. Okay, over here, if you see my cursor, I hope you can see it better. Like the cardinality is optional to one. For the first one, you've got the circle, and then the line after that. Optional to many, you've got kind of this, almost looks like a rake or something like that. Mandatory to one, 2 lines, and mandatory to many. So the circle is optional. If there's no circle there, that's a very strict rule. So we've got multiple vendors can have relationships with multiple owners or no owners at all. All right, so we've got our vendor up here, what's this called? An entity. We've got attributes down here. We've got a relationship table. You don't have to have a relationship table, but this just happens to have that. And then you see these lines in between. And so let's go back to this thing. Vendor can have relationships with multiple owners. So let's follow this down. Vendors can have relationships with multiple owners or none at all. I know it's hard to see, but it's this over here. It's optional to many. Multiple owners can have relationships with multiple vendors. So owners with multiple vendors. So if you break it down into plain English, it's not that hard to follow, right? A vendor can generate multiple service records or no service records at all. A service record must be attributed to only one business. So notice again, we got vendor with the option of multiple service records, but when we go back from service record being attached to a vendor, it must mandatory be one. Only one. We find another good example here. A repair subject can be contained in multiple service records, but must have at least one service record. A service record must service only one repair subject. I gotta remember that. Okay, so we got repair subject here. We've got service over here. So the repair subject, if you notice it, it's this mandatory where it must have one, but can have more than one. And then a service record must service only one repair subject. So it's forcing that mandatory one. So if you violate any of these relationships within the data, you're going to have errors. All right. So, you can coerce those to ensure that everything is flowing properly. Let me just check this real quick. Oh, yep, there is 2 people in here. Okay. Anybody have any questions on that? Nope. Okay. Okay. So relational database modeling is we're taking the conceptual representation of the entities into a model that can be built into a physical database. For the most part, it looks the same, right? You could combine the two together if you wanted to. I mean, nobody's telling you no. In the sense that the additional component we have, so we've got our entities, we've got our attributes, is we're specifying what that attribute type is, column type, and then we're showing where data is flowing in here. And then we're identifying, you also want to identify your keys in there as well. Sometimes you'll see another column for that, for identifying your keys. This one just has them listed at the top. We're going to look at an example where it's probably better just to have a third column there here in a minute. Okay. So normal forms are they're rules to help you decide when to maybe stop a table and start another one. If I can say that in plain English. And really it's going to help you reduce redundancy. You're going to minimize your storage footprint. I would say this is definitely more of an art than a science, which we'll see. You'll see in a difference between like a star schema and a snowflake schema, right? You really want to right size it to what you're doing. And I mean, given that it's analytical, there could be cases where you may not want, you may have everything in 3NF, third normal form, and there may be some redundancies there, but maybe that's because you've democratized data, right? And so you've got, business operators or maybe financial analysts that just want to be able to download it, and they want particular fields, and you don't want to mess around with joins, and they don't know how to join. And so your main table maybe has redundant fields compared to what, one of your maybe dimension tables has, right? Like a good example of that would be in your main table, instead of just having like your location ID and your service person ID, and then no names and no names of locations because they're on a different table, you might just end up including it because they're not going to know how to go grab that, right? And then you don't want them messing around in there unless they know what they're doing. So we're going to review 1NF, 2NF, and 3NF. So the first normal form, the table has a primary key. That's a requirement. Each column value must be a single value only. There are times where I've gotten data where, believe it or not, there's multiple values in one column in one observation. If I were to try to explain that further, let's say instead of headquarters here where it says Redmond, Washington, it says offices, and then you'll see Redmond, Washington, Omaha, Nebraska, Minneapolis, Minnesota, all in that same cell, which isn't fun, right? We don't want that. There are ways that you can break that out. We're not going to cover that, but it does happen. All values for a given column must be the same type, right? So we've gone over that a lot. Each column name must be unique. You can't name two different things. You'll learn this in your Python class. There are some nifty things that Python will do if it comes across that. And that will happen. And particularly if we talk about 3NF tables and we're joining them together and we didn't identify unique columns for each of them, what it'll do is it'll leave it'll label one of them with like an underscore X after that, or like a Y. So you know which it'll differentiate one when you join it over. No two rows in relation can be identical. We don't want duplicates. The order of the rows is insignificant, and the order of the columns is insignificant. So, I mean, we've gone over this, right? You understand that. Almost think of it as there's a first order, second order, and third order. It's not, oh, this is 1NF. And then this one's 2NF, but it's not 1NF. Like the requirement of being 2NF is the table already has to be in 1NF. The relation in the second normal form, if all of its non-key attributes are dependent on all of the key. So this one, as you read through it, it's kind of a bit like, it may not make sense here. So what it does, why does this matter? So it prevents partial dependencies. So each piece of the data relates to the whole unique identifier, reducing redundancy, ensuring that the data tied to one part of the identifier is stored in a separate and relevant table. So suppose you have a table for orders where each order has a customer ID and a product ID as the combined primary key. If you had a column for a customer address, this wouldn't be 2NF. Because customer addresses depend only on the customer ID, not on the specific product ordered. So you would store that in a different table. Does that make sense? Like you would have a customer ID in their address, and then you'd have another table with a product ID and a product, and then you'd have a separate table where you pull those both in. Okay, third normal form. Every non-prime attribute is non-transitively dependent on every candidate key. Each field is either part of a key or directly dependent on the key. Table columns do not have transitive dependency. Transitive dependency in a database occurs when non-key attributes depends indirectly on the primary key through another non-key attribute. So it's like saying it's when one attribute depends on another attribute, which in turn depends on the primary key. So imagine you're storing some information about employees, and we have the attributes employee ID, employee name, department ID, and department name. And in this case, the department name is indirectly dependent on employee ID through department ID. So employee ID determines department ID, and department ID determines department names. That's a transitive dependency. So the problem is if the department name ever changes, you have to go update every single row where that occurs. And so to avoid that, just split them up, right? So take one table with an employee table. You got your employee table with ID, name, and department ID. And then you've got a second table with department ID and the name. So data flow modeling, think about how it flows through a system. So we've got a customer, they place an order, there's some credit data that flows to approve the sale. Once the sale is approved, a few things happen. They're going to release the stock, ship some goods. They're also going to bill the customer, send the customer a bill. We're going to log when it's shipped, send it to a carrier. The billed customer, we can send them a shipping notice. And then we're going to post that data in accounts receivable because they haven't paid yet, right? We had to send them an invoice. So we're waiting for some AR, which, by the way, is like such a common data set to work with at organizations. And if they have a problem and you ever find yourself in that situation, you can literally be a rock star and like prove your value by 10 times your salary and then negotiate a bonus or a raise. Just a pro tip. Then you got a sales order, and then you got your list of AR records. So that, to me, that's like a good example of like C-level work, right? Like you're not going too crazy with it. You're just diagramming how data is flowing in different parts of the business process and where data is located. You're not listing out, right, all the entity and attributes and relationships for their credit records and how they're producing credit algorithms and things like that. Okay, so OLAP dimensional data modeling. There's not a wrong way or a right way to do this. I would definitely say the most common way is a star schema. The advantage of that is it's easy to follow. It's easy to understand. The queries are simple. It's pretty quick. The disadvantage is space cost, which I wouldn't be terribly concerned about because storage is fairly cheap. But what you watch out for is the integrity risk due to redundancies, like we talked about before. And sometimes it's, it can happen. And there are times though where you've got to negotiate, you've got to figure out that balance between operations and the technical stuff, right? So if you go back to that example, two of them, one where I talked about the transient relationships in data, where we split the employee table away from the department table, right? You still can include that stuff in there, but you've just got to be aware that you can cause a redundancy by joining on the wrong field and get very, very bad data by doing that. Or another example would be if you offered like Power BI, like people to build their own reports or Tableau to process leaders or analysts or things like that. So they can't, they're not manipulating the actual data, but you're going to allow them to drop and trend and, do things like that. And then if they pull the wrong field in and you don't have your relationships right within your OLAP model, that could also cause some issues. So it's just, I'm not saying it happens every time, but you've got to kind of take that on a case-by-case basis. In a Snowflake schema, you're going to have a lot of little tables that are connected to a slightly more central table. But as you can tell, that'd be hard to understand, right? Talk about like subquery after subquery after subquery, if it were me, and I had to stick with that, I don't even know if I'd do a SQL query, to be honest. I'd probably just load it all into Tableau or Power BI and then do my modeling in there. And then just, call whoever the TBA is, make sure I'm doing it right. Okay, so today, going over OLTP versus, OLAP, analytical processing. Somebody tell me what is a common use case for OLTP? Not everybody all at once. And people online are quiet today.
Customers, purchases, business stuff like that.
No SQL, right? Unless you maybe built some internal ERP and you're half dev or something like that. I mean, that's, but typically the OLTP is going to be supporting whatever software system that you're pulling out. And then your analytical processing is the model, the stuff we've been doing, right? Is we're pulling the data that we want. We're creating our own model for analytical purposes. We've gone over some database modeling techniques. What is the technique for C-level work when you're trying to understand how data is being passed through different systems? That'd be a data flow diagram. Okay, and then we've got normal forms. So 1NF, we always start with that, right? And then we can go another layer down to 2NF and then 3NF. Let's go over those again, though. Because if you really understand these, like, it will help you make those decisions. Like, for example, right now I'm putting together an OLAP database. I'm actually thinking about, if I can get this done in time, I'm thinking about making that your assignment or possibly your final, using the actual data from the client. And I have to pull, because of the system it's coming out of, and I've got limitations, I have to pull like 1 year at a time. I have to pull from many different tables that some have some information, some don't, and I've got to combine that together to get to what I actually need. And so it's helping me organize that schema, right? When, for example, I can only pull 35 fields at once. Otherwise, the query crashes. It's a system limitation that they've put in there to preserve resources on their end, because they've got to host all these clients on a database and they're cheap. And they're not stepping into the 21st century. So so think about like 3NF, you're going to have those little tables like that you'll combine together later. Like, I've got, Microsoft, and I've got the symbol and I've got the company, and then I've got company and I've got headquarters. I can match them directly, and then I can end up producing like the larger table later. So there's a lot of free diagram software out there. Pick your poison, try what you like. I'm a heavy Canva user, so I just use their whiteboard. I was actually surprised that I still don't have a out of the box ERD or relational database diagram with the types of arrows and things like that for relationships. But You're going to need it. So for our homework, you're going to need to have access to something. I'm pretty sure that draw.io is, I haven't used it in a while, but I used to use that one a lot, and I'm pretty sure it's still free. Visio likely has a license that you're going to need to pay for, but I do know that that one has, all the like cardinality operators and things like that in there. All right. So for today, I'm going to end the lecture part of it in the recorded live stream. And then we're going to go into an exercise.